Hello. Yeah, this is better. Okay. I'm just using this for the project and then build, and I think it's important. Give you a little background. My name's Ray. Got my work around as a software engineer for for work. So I got my educations in traditional engineering, like chemical engineering, civil engineering, and such. So, yeah, so I'm like how to say like let's say like a fundamental sciences, and then like got some of the training in engineering per se. And so becomes very interesting when I get on the software engineering realm and then find that there isn't really a standard, or like we use SDM, things like that, in chem. Yeah, so to do the analysis, to all this stuff. So, and the first just guy who's software engineer, I've been coding for a while, like for my personal project, for my thesis, for my dissertation, and all that. So like, but when it comes to work, uh, 2 years, 3 years in the working now, we have a large language model, which is fun. But like, especially when doing this, why? Because like, especially recently, like people start aware. Like I have always a hunch about right now, like everybody begins to aware of this, like talking about some way to compile a language, it's like that. Like what actually, like in terms of communication with large language model, I'm just gonna share my screen here. It's just a language model. Turn screen. Share this one. Yeah. In terms of a Lagrange model, in terms of a communication, like anyone that working software engineering, got the, as working as a developer, things like that, and basically, like you want to, if you got some experience in it, you kind of feel that the most difficult part of software engineering is actually not, you know, coding itself. Coding is fun. More or less fun. Coding is okay. And then combined when it comes to the really difficult part is actually communicate between your client, your collaborators, trying your colleagues trying to do two things. One thing is figure out the logic behind, figure out like what exactly do we want to do. Like I want a shiny black, right? I want a shiny black color on your CSS. What does that actually mean? Like you know or like I want a very colorful black. What does that mean? If I want a something that I just say like I want a bloom effect. Like what does that mean, right? Or in the computational eyes, you want to solve a problem, like you want to solve a ODE, ordinary differential equations. Like when you say that, like you got a lot of ways to do it. You got software, you got tons of software, you got lots of things out there to do these things. Now the problem is that when we talk, intent is very vague, and then the intent, the target is very vague. That is hiding behind the languages, and then when any language or any text or speech that is taken out of context, things becomes murky. Things become like when the actual intention can be hidden behind a uh, poorly worded question or poorly worded statement. And then and then when verbal statements comes down to the paper, it changes a bit again, right? So when it comes down to paper, when formal documentation, or when a documentation of a dialogue turn into a formal documentation, meaning can change. Meaning can change and is very likely to change. You know, yeah. Again, so now we use the vehicle of a language, right? Human use the vehicle. use language as a vehicle to deliver intent or deliver thoughts or to convey thoughts, but now through different, from word of mouth or like when the information is passed through any kind of a vehicle, any kind of a pipeline, and then we reinterpret it, and then everything got lost, or NEC, things got changed a bit. So, it's the same thing when we're talking about language model. That especially this time recently, you see that language model. We, in the very beginning, we talked about alignment and things like that, and then like an alignment not just in the way that the way that different languages are being meaning aligned, but like in different field or even in different sentences, in different contexts, the same language can have a very different meaning. The same word can have very make a lot of different meanings, and then it becomes, if we're using a language model as a way to do a communication, do a quick chat, to do a Google, use it to do a Google search and things like that is fine. Why? Because you can align your language later on in a discussion, or it is quite easy for you to spot what's wrong in language mode way of understanding your words. But this can change a bit when it comes to coding. What I'm saying specifically for coding. There's one thing that code, at least to my knowledge, to my poor knowledge of the field, that currently anything runs on our silicon are deterministic state machine, right? So technically speaking, there's no probabilistic unit. May arguably anything that does your, any app or scripts that does your achieve a certain function is a deterministic. It is deterministic in a way that how you can interact with it in terms of the states. And then what really happens here is that when we ask a language model to do a coding, language model understand, it can, in its wording or in its output prompt output, you can have language model describe the script that it is written to you. But the intent or the function is one thing in the script it generated, right? You can write as many unit tests as the things that you want, but the intent of the script, the actual, the actual intention of the script doesn't necessarily match the description that you have. Given an example that, I want the adder, right? So everybody so you have this notion, right? So if I want to let large model, so if I'm a coder, right? So if I want to add an adder, I can use directly, in the code, I can use the operator add, right? You can have 1+1, 1+2, and things like that. But adder can also become string, right? You can do string adder, like the string at 1 plus the string 2 equals to onetwo, right? That's another adder. You can have a state adder, right? You can have like a one state. If one state is false, true, the other state is false. One true plus one false, you can get a false or false true, things like that, right? So, or depending on the rule, right? So when we say adder, like all this intent are hidden, right? If I don't tell you, or like in a prompt, I don't tell language model what kind of error that I want, it's very likely that you return the simple error that 1+1, like generally understand. The mathematical actually can spin up something to do it. I'm not gonna do that right now, but yeah, you get a point. So what's important is that, but like in the script, imagine it's not an adder, but it is something that is you ask it to generate you a whole app, right? Little web app that you can use. Problem being that in a if they generate a lengthy script, you generate a complex lengthy script, right? You can describe the function of an adder. You can describe the things that you build, that they build. Problem is that the more complex, not even complex, right? Even in a single Python script that is 100 lines, 200 lines, there are subtle things that you can miss, right? There, like what it says in the summary you provide, language model provides you, doesn't necessarily can align with the script that you write, right? We talked about that before, when different, what logic is being documented and things like that. Things gets a little bit murky. So now the problem becomes like, what exactly, in terms of course, this is all in terms of programming, things like that, right? You want to write a program, you want to write something that you actually work. So now the problem becomes, how else am I gonna, you know, if language, if the plain language that we describe is very likely not likely to carry the actual logic or intent for a state machine to operate, then its very nature, it's the, it naturally transition to that we need a we need to discuss on the actual logic level. What does that mean? Say, if I want an adder, specifically speaking, right? If I want an adder, so in logically speaking, right, when you have an adder, you have input A, you have input B, right? If you want a numerical adder, you always say, input A, you do a type check, input B, you do a type check, and now it expands, like if you support more than two numbers, right? You support a series of numbers to add into it, right? That's another check whether if it's a number of input is if the number is inputted for return something. So that is all that all can be written or solidified or clarified into a flowchart or into a logic flow that will help you document all the things that you actually to the every beat, so that your intent, so the intent behind or logic or intent behind the language is being exposed. What that will give you is the ability. You can read about this. This is also AI generated. I read it a little bit more through it, but like I want to describe the full meaning of it. So let me just give you a very example to build in Python mass compute. This is what I'm talking about. Yeah. So, like this is not adder, but it's the state machine. So for calculator, right? So now my intention is being solidified in here. We'll have a gates, in terms of the philosophy I can do it later. It's pretty late for me. I need to go to sleep anyway. So again, for state machine, I can define it as it has the states, gates, it has actions, it has transitions, things like that. What it allows me to do is that I have my mass computation, right? I have the mass computation that it has, like whether it has operands, things like that, what it changed. This is a mass computation, so it's a simple math, right? The set a certain like calculation, requires I only do two numbers, so if I do two numbers, things like that. So the intent is being solidified into a state machine or the state workflow, right? So I bet that there's other tools out there that I'm not aware of. Working like from a cross-disciplinary, I know that one thing that I learned from cross-disciplinary is that like one thing, like each field has its own treasure that is completely hidden from the other fields. Like mathematics or things like that will have similar like symbolic calculation, symbolic representation of the certain states, right? But for me, like I'm not a mathematician or any sort. I'm trying to build something that is for me to communicate with Lagrange model. So to express my logic, this is the way I choose. Okay, now once you have your logic solidified into a workflow chart or into a state flow, and then you can now visually see what are there. If I have an operator, and then you check when I have an input, what if I have an operand, what have an operator, if any. If has an operator, if it has another number, you go back to the operand, right? If I do the clear, so you will just clear it. And then if I divide by 0, there's gonna be error and things like that. So what that does, so once we defined, for example here, right? Once we defined our states, right? We state in the state we have operator, we have operands, like equals to waiting for the equal sign to do our operations. And then we have like in the case we have in this one where I defined it as adder for 2, right? We have if we have first number, we have a second number, right? If we have operations like a one, like a one minus, like the four operators, right? If I have a checking for if I have these two variable has anything that's stored, if there's any error and things like that. So now by having, right, so display rules whether the something's error, something will be show off. There's a this so like a plus b, so there will be like an a operator processing like that. And then we have actions to define what like what actions that you're actually doing in a certain other state. And then you have transitions that to say, how what basically the edges between the nodes. So the a simple compute machine solidify into a flowchart or or state machine kind of thing. This is my understanding and my thought of how to build some sort of thing like this. I have like what's that the transition gate action three mean states, and then we have like rules, things like that. Four basic atoms, three rules to define this very base logic language or logic flow. So what this allows me to do is that I can express a complicated workflow into or any kind of a workflow that is deterministic, or again, based in current silicon based computations, most are tooling complete. So technically speaking, it's able to describe this kind of systems. And then once you have something like this completed, so when you then have this graph communicated with language model, there's no ambiguity. That's the most important part. There is no ambiguity. Connections, once you have the rules, basically you have every rule set, whatever, your logic in your mind. This is how the logic flow should go. That's how the mental flow should go. And this is how the mental flow should go, and it should solidify. And then this is your code. This is your logic. Like what we say, like a lot of YouTubers, like we all say that now the how do you put it? The logic or the asset that you have created in your job, like scripts are not an asset that you created, but the code is not what you created. Is that's your asset, but the intended logic behind it, right? Your business logic, the way that you're taking care of the way you're taking care of the error and things like that, right? You throw certain error state at a certain location, and then to capture some kind of thing, you have a design a way to smartly handle some kind of interaction between the user and your interface and things like that. These are important. But more importantly is that, previously a lot of the time, even we have a design document, things like that. A lot of the time, when you're trying to fully express your logic of the code, you can miss or you can have a misalignment between the logic that you draw out and the true implementation that you have a code, vice versa. Because simply because, like if of course I'm not denying that there is a lot of people, like have the ability, or like that's the job, very good in documenting some of these things. But most of the time, that at least in my experience, is that you have some missing due to a variety of reasons, like fast revolution of the script, you need to do a hotfix. But when you throw out a hotfix, it's very easy that you miss certain kind of documentation update, or there's some like differences between the documentation, details requirements between um, what was initially designed, and then later on client or the cover just saying, hey, we need to do something different, or I want to add that, right? Everybody being there. So so this what I'm doing, or what I'm saying is that how about let's just take it out. Let's just talk about the logic first, and then we'll talk about something else. Now, why is so this why is this why am I bringing it up now? Because from logic to code, previously we don't do that, because if you discuss logic first, logic discussion in itself is not that easy. Second, if you discuss logic first, if you build a JSON like this, right? Previously, we need human to implement this JSON, or we need somebody to. If I build something like this full kind of full things, right? It determines certain state in terms of operation, in terms of a script to actually do some job. You still need some custom code or like a action code to do it. So it becomes a, how do I put it? It becomes a overhead, right? It becomes an overhead for a lot of the teams or individuals and teams to actually implement, do a quick fix, or do some to create a feature. And then at this state of at this age, at this time, as you got a lot of room for errors, right? You can basically hotfix, you do the deployment, things like that, right? So you can do your, it is okay that if you can do the most best job that you can, but it is okay that you have some flaws in there. That's fine. It's the same thing. Is that it doesn't change anything right now in terms of the depth out. But what language model allows us to do, especially when Gemini 3 and Gemini 3 and well, I should say the 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 Claude what's that, Claude Opus 4.5 out. It is super powerful. It's basically reduce you the difficult, take out that kind of a co-implementation step for you, take care of the co-implementation for you. So that's why everybody, buddy, like you see a AI video, they all say, like a code, like AI can dump massive code, can write massive code out, and then we all hope. But the problem, when the AI, again, we saw the very beginning of our discussions, that if the AI can dump a lot of descriptive language, right? Yeah, eventually scripts, code, or language. If you have this kind of language out, the intent is again hidden in the language, and then implementation, there can be misalignment and things like that. Like you now your job, your human job, let's slowly switch to review the PR a lot of the time. Look at me, right? But now to take it more seriously, that if if I want to later on, if I really incorporate this in production or created implemented code into some serious consideration, that I want the logic, if not the code, I want the logic at least to be laid out for me to review, because you can have 1,000 lines of, of code. When it condenses to a logic flow, it can be surprisingly small, and then you can spot something that's really fast. Okay, so this is a simple example, right? You can have a discovery shopping. This is another one. This is it becomes a little bit different. Like you can this is I think this is a one shot that have it could, like it has the scripts. It has the this is what I'm talking about. It has some like the function scripts and things like that. You use the Opus 4.5 generated the code. It has a lot of things here, but it can has as many things as it has. But when it condense into the code, like you can see like all this kind of I'm not a maniac. I'm not gonna be able to remember and recite and every details of this JSON. But what the power of the JSON is that a very well structured thing can very easily compile into a flowchart. Marmite in this one I'm using. Actually idle I for any I can reset, right? I can select the category idle, go into a category. I have a quizzing, basically ask me to do something, right? So after the quiz, if it is complete, we are going to the fetching stage, do the search. If there's a fetch more, I'm gonna fetch more of this. After fetching, we do the retry and things done, and then we do the analyzing, right? There's just not done error, go to the error. If it is an error, we do the retry and things like that, or like do the retry, anytime I can jump back to the idle, or if in the ranking if there's down the ranking, I'm done. Go to the browsing. I want to refine. It brings me to the quiz again. Even that, I can just compare, like comparing these kind of different kind of stuff. I can review the details for anything. So, and then I can set alert and things like that. So to have this run somewhere, I had used to have this run, and then basically this is what it is, right? So it's allow you to do all these kind of things. You'll be able to review. You have with all these codes that's there, you'll be able to review what's going on. So that's just an example here. So now when it comes to easy to comes to this one. So okay, I have this JSON file, you have this defined, you have logic defined, where so what? You can have this conversation, you have this file generated and a discussion with AI. This one I'm advocating, or I'm advocating is that you know, previously we have a compiler language. I'm using Python, but like there are compiler language, right? So in the compiler language, it basically force you like Java, C++, and things like Rust. I wrote the Rust or something like that. But if a compiler language is able to do the type check and all that sort of basically compiler language basically, to my understanding, is you will do a pre-check of your code based on certain syntax or a certain rule that can only it runs if you have those rules implemented. You follow all the rules that it requires. Same thing for the logic. So here's the thing that if your code right now is compiled from a logic, then what enforce is you have a completion of logic, right? So now implementation is not a business. The structure, the basic structure of your application, the script, has nothing to do with the code that you generated. The target code you generated, right? Right now, I'm most familiar with Python, so I'm generating my script with Python. From Py, I have a compiler, right? From Py, yeah, this is a Python frame. So I have a compiler, Python compiler. So basically, it allows me to compile the JSON code, compile the JSON blueprint into a working a function in Python script. What that allows me to do is the enforcement of logic, right? When we discuss with large language model, we can have a set of logic set. And then when it comes to the true implementation now, at least on the framework level, right? This language, your language, your workflow is being enforced by the compiler, by the way that this is being compiled into. So you don't miss anything, right? Or like there's no ambiguity between the implementation and your discussion. So that's the basic idea, right? You write logic, you discuss with large language model on logic level. You have because human, we do when say like a human or us, we can do high level of logic deduction and things like that. We can think, leverage us, right? We can think in terms of a graph, language model, of course, the graph reasoning rate like is very, very hot topic right now, as if like January 5th, 2026, right? Like graph reasoning and things like that. This is the emergence behaviors of language model and things like that. It is all nature, right? It is nature to the human that we do the graph reasoning and things like that. So we reason from graph, we understand the workflow. We now like when the room of collaborators, you engineers, collaborators sit together. Now we are discussing the logic flow of it. We look into this graph. We imagine. We use our imagination to think. If I'm at this state, what I can input, what hasn't been checked, and then this logic state, different logic state, and that can be add into the JSON state into the logical blueprint that you have, enforced by, and then you can enforce by the JSON blueprint and goes on. So with the help of a large language model, in terms of compute and things like that, say, at a certain stage, I want to say, I want to have like the example that we have here is discovery shopping, right? Uh, say fetch, right? Fetching, you can use Google API, you can use DataGo and all the engine, you can use simple crawl, things like that, right? So when it comes to whatever is doing the actual work that's coming from the functioning script or compute script or compute node that luxury model compute writes, right? At this stage, in a higher level, in a higher level, you don't really care how it does it. You just want in terms of a workflow, process flow, that you care whether it is fetching or not, right? It is fetching the right things or not, right? Or not even fetching the right things or not, right? Is it fetching or not? Like, does it return a value and things like that? And you can do, you can do the gating of like whether the fetch has returned something or fetch has not returned something, right? And then you can implement another gate saying another action saying if the fetch, whatever fetch it has matched, text similarity and things like that, for to do your validation, right? That's depending on your engineering task, how much detail you want to make control of it. So this allows you to leverage whatever it is the existing workflow that's out there. So now, with this, now when talking about engineering importation and things like that, what we arrive at is, let me see. Yeah, executor. What we arrive at is basically a framework that will enforce the logic blueprints that we discuss with language model, and then the execution is being, the implementation is enforced by the logic that we have established, and the language model can help us implement the compute part, or we can implement the compute part, right? Compute of course has its own language and things like that that will allow us to effectively really quote unquote communicate or build with language model. Why? Because of the consistency. The compile you can have a different logic approach to it. You can have a different logic approach to the same thing, it isn't. But this logic, if we preserve the logic and then you communicate with downstream model on multiple level, ask it to generate, according to a certain schema. Like this is the example I built. It is pretty ancient, right? You build it with a certain schema, right? The enforce, at least right now, language model is pretty good. I follow the schema structure, and then you can have a tool to validate it, right? So this is, you can really describe the how things are going. You can really visualize how workflows are, how your logic are flowing to the works. Okay, it can be a little bit vague on this part. So this is, this is a video and just do the short introduction and some of the things that I made here. Yeah, see, this is nowhere to down for. That's where language model can generate a lot of the weird things right in here, but like technically speaking, you don't really need to care a lot of everything here. Okay, now I'm gonna show you I'm building with Claude Code. Building a lot of I already built ever since I established this workflow. I'm building all my utilities under this workflow. For example, right, you can build a Lagrange model system. In a Lagrange model system, you can see the structure, right? Diagram, this is mermaid diagram. You can have like which state is flow to what is essential. Like this is a lot easier to review, right? When you come to the actual compute, this is what I'm talking about, right? When it comes to actual compute, I don't really care about what your actual compute is, or like I do care about them, but like you can sort of see the point here that these are functioning modules that will come in and go, but whether it is how it is implemented by large model, sure, of course, but in the higher level, I'm not operating like I can operate at this level, right? Or I can operate at a higher level that where this in terms of general behavior, what a general behavior I want with this, with this model. Like I can, like I can go to, yeah, this is some control. No, this doesn't allow me to do it. Let me do this on the web. So if I go to utils, right? If I go to language model systems, this is just something that I built from the structure readability. Yeah, right. See, so the initialization, get ready, something is get bad, go to the query and things like that. This is kind of the flow, workflow I'm entering, the state I'm entering, right? So I can inspect whether, for this one, I have everything, I have something goes to error. So if anything, if any state, right, is ready, I don't see, yeah, ready is connected. I don't see a Reddit that is actually connecting to the query. So Reddit is just a transitional state where it's gonna feed into the querying. So querying, if it runs any errors, if anything runs into the error, I can go back to the initialization. So this is the way for me or for everybody, to or for human engineer to know that if this workflow is what you want, right? If this in a big picture, if the behavior of this large language model is what you intended to have. Now, yeah, so in terms of actual implementation and things like that, right? So the compute function implementation, CLI something, right? For it is we trust Opus, I trust Opus a lot, 4.5 a lot to do the job it's supposed to do. But again, like I say, if there's any misintent hidden in here, it is my job to capture that in the scaffolding or in the infrastructure around it, right? So in this case, if the querying is returning error or like if there's anything or misintents in the querying part, right? So I can add another check here. I can write my own check, compute function. I can write a check. I can do a state check here, or I can do a unit test here, or the small test samples here, right? So What that means is that if the querying is returning something malicious, or if there's anything that is not right in the script, I should be able to capture it. Or in terms of the engineering wise, I can write something to capture it. I'm not writing it right now in here because this is an example utils that I have here. But the thing is that I know where to exert control. It is like when I was in chemical engineering, right? You want to have certain control, right? You want to have your pressure valve somewhere, you gauge somewhere, you can test your pressure, you can have a lot of you can exert control on certain, like before after the valve, you can have a bypass as a maintenance bypass and things like that. You have the ability. Now, in this kind of thing, you isolated the feature, you isolated the operation from the process. You isolated the reaction from the process that allows you to have the ability to exert control on the locations that you think is appropriate or you think that is needed. Whereas like most of your code that you write in your production, or most of the code that you write in your work, is likely to be this kind of a process that's engineered, that's industrial, that's engineered, that's the process control. Whereas the main compute part is most likely something that you import in NumPy, and then you intrinsically trust NumPy to do the job, as we here intrinsically trust the large model to do the actual compute, while we exert the inspection, human exert the policy level governance over the process. Right, that's where our value comes in, as we exert the process governance. So I think I'm just gonna. It's getting pretty late. I need to go to sleep. If anybody is interested, they'll probably do another video. Okay, so what this allows us to do is that I can build something like that. I can build a workflow. So uh, let me show you something interesting here, because what in terms of documentation, things like that, what I'm able to do, build rules, that's docs, in utils, in dashboard. Why it allows me, because everything is structured, because your logic is structured, because you have your structured logic and things like that. So for example, I have a function called decoder, right? If I open the logic graph, you sets and then put it in circular. Most of the time it's in circular, right? So this is something that I built to decode a Python function, Python script that is not written in a way that it is a state, is the LPP state. Oh, by the way, the frame that I built is called LPP. And you guess where this thing comes from, but like for me, it's logic. The plus is to plus logic plus human and plus carbon plus silicon. So it is the way for human and language model Silica to do the logic discussion. So say, if I have a happy path, normally speaking, I will go to loading, I go to analyzing it, good. So basically all this kind of stuff, right? I can do the failure path, of course. Everything can fail, right? You can go to the reset and things like that. And then you go to the complete, right? Failure path node and things like that. And great. You can see this kind of a transition and things like that. And then I can spot, like you can spot this one. Do I have an error state? I don't think I have an error state in here, which is a problem. Okay, I guess the complete is one of the error state that I have. You can have a decoding. You can have a, how the language, how each of your process is being, how each of your process is there. Right? Logic decoder. This is a similar thing. There's a visualization doesn't. Oh yeah, it is being. There's a visualization that basically hides the logic state, I guess, the error state, but there's error state everywhere. Anyhow, but you see, like when we reason, when we reason through visual, right? when everything is decoded, right? When the logical mean process logic is being extracted, we'll be able to exert control, exert governance, like think on the graph level, and then we communicate on the graph level, and then we compile the code into enforcement, compile the logic into code in terms of enforcement, and then we go from there. Scale registry, and like you can also explore the function, things like that. So yeah, so that's the from a compile. So in a nutshell, we want because of the ambiguity in language, whether it's the same language between the written and the verbal, different dialogue, different countries speaking, different region, and the intents behind or logic or intents behind the language is very hard to document. And then a lot of time, like lost in translation, lost in documentation. So if your intent is lost in documentation, when you communicate with a language model, your intent is lost as well, unless it is written in a way that's not ambiguous, which is in a logic flow way, in a logic documentation. In a logic documentation, you can now enforce logic implementation. You can enforce implementation from the documentation, the logic flow, the flow chart here. All right, you can enforce the implementation through compiled through logic, and then with this implementation, human now stand at a point with language model to do a governance job in the process design, governance job, logic process design, governance job. That's actually valuable. That's the most valuable thing that you actually, generate when you as a coder or software engineer. And that, you know, and that interface, like right now, as much prompt engineering as you can do, still you are on the language level. But I'm from but we need a lot really the infrastructure as the logic as the infrastructure or some kind of infrastructure allow us to compile the logic, right? We communicate directly from logic, and we really do work in terms of logic rather than logic and then enforce implementation for compile rather than having language model to sort of guess your intent and then implement. And that's by implementation, if we have the logic flow, have language model to implement it, it is very likely that there's another there's another there's gonna be another layer of error through the transcribe of the logic into the code, which is another language, right? Another written language. Right now I'm writing in Python because the Python is becoming now the most familiar script language that I have, right? You can actually think this language or this state machine can be implemented in whatever compiler that you want, right? You can compile it to Java, you can compile it hell part of my language. You can compile that into especially Rust, C++, and things like that, right? You can compile it into the language as long as somebody write a compiler for it, right? Compiler for it. You can compile into this compiler language and have the compiler language do another layer of subject for you in terms of code syntax. Whereas right now I need to do the syntax check, all that thing myself here. And then, so in this way, that when you are communicating with your, say, I have recently built this one, README. So I have, if you are able to receive all the scripts that you have, right? Every, we have the luxury to view inspect the previous scripts, all the previous statement scripts that we wrote. Technically speaking, we can do if everything is solidified into a script, then we should be able to expect what's wrong with the script or what's there with the script. And in terms of us communicating with the language model, ambiguity, so state fix, compile vulnerability, state machine, flow, state machine. Yeah, this is, I'm not sure why it is not. Yeah, this is just a self-evaluation. State audit, I can audit state, I can audit this. Yeah, this is pretty big. Yeah, I can audit the state of myself, right? So with the ability to review, see the gaze has no, yeah. So that's good. I have the has arrow right in the face. Yeah, I have the arrow face and things like that. So I'm able to audit a very complicated workflow that currently has, and then I can ask, you can now provide, right? You can now provide a more easier syntax, right? Say, see, we can do a communicate with long-term model in terms of a faster way that now communication, like it doesn't need to read through all the scripts that I'm implemented here. I need to read in this just one implementation because all the future implementation or your state logic is being implemented in here. And then it needs to read this workflow and then state hits, and then you can write code and then write state to analyze this JSON script. And then by analyzing it, you provide it. Basically, it's an overview of workflow, and then you provide you the analysis or things like that that you want. I mean, there's lots of coverage. So this, yeah, it can do now. Like when we say code doesn't, language model doesn't have the logic, I think a lot of time is because like it really depends on how you define the logic, right? So, so a lot of times, from my understanding, it does have the ability to reason, reasoning ability. That's a reason. Does it have logic? Probably yes. Why? Because reasoning is based on a certain set of rule, which is the logic, from my understanding, of course. So you see all this, right? Error handlers, it can be a similar like mistake using graceful degradation, things like that. This intentional fix. Yeah. So you see, the communication now becomes more effective as we go through this kind of logic state. Right? We have the ability to determine, when I review the image, when I review this workflow, when I want to do the review, when I do the governance, it's easier for me to do the governance. When I do the implementation, I can migrate this to anything that I want in terms of a language. And then, because logic frame in itself is self-pointing, you can I'm able to describe my own LPP frame using the rules that I said in terms of logic. So it is, it is pretty neat. Yeah, and there's a lot of other features. For example, I added the TLA plus, right? So basically, it is the way to it is way to validate your state machine. I highly recommend it you to look things like that. I'm still taking the course myself as well. This is a tool suggested by J-3, and I found it very insightful. Right. Now, based on logic, you can now do from a logic standpoint, you can now do a lot of validations, like without, you know, how do I put it? You like the few unit tests or integration tests won't catch whatever logic flow that you inherent logic flow that you have here, right? So that's why I'm building this one as well. Like I have two workflows. One workflow is Python to LPP, right? So that's my like migrating. I'm already migrating my old project and start migrating my old project. I already migrate to that is migrate my old project to LPP where I can insert more governance. Uh, governance view on it, and I have a better insight into what I have built in terms of logic. And then the second one is this one is what I just built, and you can see defined as this, right? This is self-pointing. This is a sort of a self-pointing, self-reflecting workflow that I built. So this is the logical vulnerability, technically speaking. If I scroll up a little bit, you should be able to see here. So I can, because because this is everything Python script that we write currently, I think, correct me if I'm wrong, of course, that is deterministic. So in terms of behavior. So if it is deterministic in terms of behavior, one behavior is not like, hey, generate me a random number, and that random number is deterministic. Technically speaking, yes, in terms of governance, right? So if you have an input, so imagine this app, right? You have an input, user input. You have an input, you give it, either a range or just a clickable button. This one stating, right? You render generator runs as the second state, and then the finish of your generator and outputting the result is the third state. Whereas these three states will have its own deterministic way, right? If your basically is that your random number generator should return a number, right? What like in terms of whether this number your random generator is actually return anything that's random, it really depends on your the way that you're checking it, right? You can test like 10 times, you can test 20 times, you can test 30 times, whether every time it is different, or you have a grace period, you have a grace that if you would like floating point of if you set a floating point to a certain level, you might have overlap too. That's the governance, right? You see, that's the governance part that it's the engineer decision that you need to make, or you and your team need to make. All right, and then yeah, I can have a because you know I can have LPP. I can you know to me I can have LPP to go into any one of the report, identify, extract the backend logic of it, state logic of it, and then see what's wrong with if the governance error are complete, right? If there's any error that is in the governance, or if there's warning in the governance. Why I'm saying that because right now it is very easy for language model to inspect your code and for language model to write code, right? Yeah. So if the code is not written in sort of a logic based or enforced logic based and enforced structure, then technically speaking, you can trust it will do the things that you want, but you cannot trust it to have all the governance that you would like to have. This is, this kind of thing is for me to ensure that the code that I write with language model, or the code that I write in the past, for the code that I have to write if I have this vulnerability patch, because yeah, the emergence behavior will most likely that if you it is very it is easy and it's easier than before, ever easier than ever before for models to act to have the ability to have some agent or autonomous scripts to scan through your repository and then find the vulnerability that you might have. It's just, this is a in a lot the governance logic wise, right? And it's just it has never been a better, more challenging but more fun time of all in terms of writing scripts, writing like a logic. Basically, this is logic workflows. Yeah. Yeah, there are so much more I can talk about, but it's already late, and then this is just the first video. I guess nobody will view it, or like it'd be very few views, but anyhow, yeah. So I just want to document it, and then hope I don't need, yeah. Hope this will, you know, trigger some, trigger some thoughts, and then share with me your comments if you find this one buried somewhere. All right, ciao.